Okay, so we're back just right where we left, right here. So I've explained how we cap the maximum velocity, but how do we add the velocity? Ironically, I did not. I kind of skipped over this part. Whoops. Anyway, so let's see how this is done. So by default, we're going to try to move the player towards the forward and right direction of him currently. However, if we're grounded and we're on a walkable slope, then what we're going to do is we're going to move the player according to the slopes forward and sideways. And what I mean by that is I think we still have this. Yes, great. So I will just visually make this a little longer so we can see this more easily. Great. So if this is the normal of the slope and this is our player. Here he is. And well, he's kind of small, but never mind. And the player wants to move exactly diagonally to this edge, to this vertex. Then to do that, what we need to do is we know that he wants to move there, so that is his current forward direction. And we need to simulate as if we just dropped this vector onto the slope. So if we were to drop this vector, it could look, for example, I'm going to draw it with another color. This is his direction, and we're dropping the vector and say it hit this point and this point, or this point, just a little bit of an angle between the two, or a distance. So now we know, okay, so we know these 2 points and we can now move the player along that direction. This is very similar to vector projection. Maybe it is. I think it maybe even is. And the reason that I have this strange piece of code and not just simply vector3.project on plane, because we do have the slope normal. We don't, because I deleted it actually because it's a variable I did not use. Anyway, the reason I did not do this is because for some reason, when I used the project function, instead of getting the projected vector, I got the projected vector by a small offset. So if the player really was looking right here, so like say this, with the project function, I for some reason used to get a direction that points somewhere to. Oh, okay, this is a bit of too much, but somewhere right here. And so what I did in order to overcome this issue, which is a little bit ugly, but maybe not, is I used an intermediate object to store the rotation of the player and then use the transform functions like forward and up and right and rotate to get the orientation right. So let's see, where is that? Here is the orientation, and we have the orientation helper. These are just values I used to check that it actually works. We can delete them safely. So what this does, once again, we simply cast a ray down to get the normal. And if we hit something, which is probably a slope, and we just do, this is also just a simple check that I did. Anyways, if we did hit something, we set the helper's up direction to the info.normal. And then what we do is we rotate this transform around the local spaces up, just like we do here, by the amount of degrees that we are offset from the player's body. So let's visualize it. So say this is our normal, right? So now our helper's orientation is right here. And we can say that oh my god, so the forward of this object that is sitting right here, I think it's denoted by a blue vector, is going to be just right here. And then what we do is we take this vector, and if our player is, just like I said before, pointing from one angle to another, so let's just for fancy reason assume that this is exactly 45 angles, although it's not. what we're going to do is we're going to rotate this vector on the plane by 45 degrees. And once we did that, and once we rotated him by this amount of degrees, back in our rigid body player function, we can use the transform forward of our orientation object to know in what direction is the current forward when we're standing on a slope. And from there, it's going to be kind of normal. We just okay, it's going to be kind of okay. Never mind that. We're just multiplying by the forward value, which is the input. So it's going to be -1 or 1, just like we set in the update. And then we just normalize the direction, and this is a debug flag we can turn on. And then we check if the player is not grounded, so he's in the air, then we just want to limit how much force he can apply on the player. Just a fancy thing I did. If you can disable this, or just set the air movement to 1, either of those. And then we just apply the force to the player in the direction multiplied by the walk force. So yeah, that's how the player is being moved. And the last thing we have to do is the friction forces. So first of all, we are checking two conditions. Is the player, if the player is not on a slope, he can walk, or if the player is not grounded, or if the player is still moving, we're not going to apply any forces. So this one is pretty trivial. If the player is moving, we don't want to stop him. And this is also pretty trivial. If we are like jumping in the air, then we do not want to stop him. This is less trivial because we're just checking if the player is on a slope. Well, if the player is on a slope and is sliding down, we also don't want to stop him. And so I left this here. So we only want to try to stop the player if he is not moving and if he is on a walkable surface. And how this is achieved is pretty simple. First of all, we check if the player's current velocity is smaller than a set threshold, which is the minimum velocity. And we have seen this right here. Then we're going to instantly stop the player. And the reason is that by applying forces, we cannot get exactly to 0. So, or maybe we can, but I was just a bit of dumb right here. Anyways, I just did that if it's smaller than a set threshold, then I'm setting the velocity to 0. If we are not falling under this velocity, we're just going to apply a force to the negative direction of the player's velocity. So we take the normalized vector of the direction of his current velocity, we multiply it by -1 to reverse it, and then we multiply by our friction multiplier, which we can set right here. And that is all. That is how this rigid body player controller works. I hope that you enjoyed my explanation and that you find it useful. If you have any questions, then you can just shoot them in the comments and I'll try to answer as most of they can. And yeah, that's it. See you guys next time, I guess.